Okay, everybody, some notes for today. Hey, welcome back, me. It's good to be talking to you guys again. I'll see you in class this week. But we've got some notes today. First on page 43 or 57 of your toolkit, and then the next notes are on the next page. This first page is just some vocabulary. Look at that, algebra vocabulary. So find your page, pause me if you need to, and then click back in. And vocab here we have, I'm just going to highlight all the terms, and then we'll talk about them. Okay, so variable, you should know what that means. A letter or symbol that represents one or more numbers. Often we're using X for our variable, but it can be any letter really. Expression, you've seen them, but an expression is just a math statement that doesn't have an equal sign. You can see the examples there. A term, we've talked about some of these already earlier this year. Term is that part of the expression separated by addition and subtraction. Coefficient, that's a big one, and I'm not sure if we quite know what that is. Coefficient is the number in front of the variable. So in 17x, 17 is the coefficient. In 15x squared, 15 is the coefficient. In 2x, 2 is the coefficient. It's just the number in front of the letter. Okay, that's coefficient. Constant term, that's a number. That's it, just the number. Constant term is the number. The number. So that is not being multiplied, like not the coefficient, but if you had like x plus 3, the 3 would be a constant because it's not with a variable. And factor, well, factors are the numbers we multiply together to equal other things. So you can see the example here they're using with distributive property, 3 times x minus, or 3 times, sorry, 5 minus 2x. 3 and 5 minus 2x are factors because those are the things that are being multiplied together. That's it. If you need more time to highlight and mark this down, pause. Otherwise, I'm going to move on to the next page, which is page 44 or 58. So get yourself there. So now we're graphing inequalities. Inequalities mean we're using that greater than, less than, greater than, equal to, less than, equal to, and we're graphing these. And graphing these is actually quite easy. I'm not going to talk about solving today, just graphing. So we're going to put this at the top. And as we talk about graphing, it'll make sense. So we have greater than here. It's an open circle. Less than, open circle. Greater than or equal to, closed circle. Oops, what did I do there? And less than equal to, closed circle. Okay, so how do we graph these? Well, if we look at, I'm going to give you a couple examples. Let's say we have x is greater than 4. Simple one. Okay, to graph these, we draw ourselves a very short little number line. You really only need 3 numbers on your number line. Now, I know in the example they used a long one because they're not drawing it themselves. The number that you have, which in this case is the 4, is going to go in the middle. On each side of that number, put the numbers that would go there. Above 4 is 5, less than 4 is 3. So right, there we go. The number that we're graphing is the 4, the one that's there, but this says x is less than 4. So I'm going to go to that 4 and I put a circle there. Now, which kind of circle do I put? That's what I look up here to see, right? Is it the open circle or the closed circle? That's why we did that. This one's open circle because it's less than. That means 4 is not part of the answer. The solution is x less than 4. That means any number smaller than 4 is a solution. So we draw a line with an arrow going in the smaller direction. Now, if you're not sure you did it right, take the number in that direction, 3, put it into that statement and ask yourself, is that true? Is 3 less than 4? Yes, then you graphed it correctly. If you had drawn the arrow towards the 5, that wouldn't be true. 5 is not less than 4, and your arrow is going the wrong way. Okay, so let me do 2 more here. X is greater than negative 6, for example. Okay, I'm going to draw my little short number line. Boom. Going to put the -6 right there. Now remember, I need a number on each side. Now going to the right, that would be -5. Going to the left, that would be -7. Okay, I put my circle there. Look above. It's a it's a less than again. It's a less than, it's an open circle. Now, x is less than -6. That means smaller, right? The point points at the smaller number. So smaller on the number line means it's moving to the left, so that direction. And again, you can double check that by taking that number that's in that direction. -7 is less than -6. Is that true? Yes, it is. -5 is bigger and -7 is smaller. So there you go. Now, what if I have a greater than, less than situation, or equal to situation? So let me do one more. X is greater than or equal to, doesn't matter what number I pick, let's say 10. Okay, so I'm going to draw my short little number line, put 10 in the middle. One bigger is 11, one smaller is 9. Now, I draw my circle here, and I look up above and go, oh, the dot that's there is colored in, right? So I need to color it in because the equal to part means that x could be equal to 10 or greater than. That statement says x is greater than or equal to 10. Well, equal to means we have to color in the dot because it includes the 10. So, and greater than means in the bigger direction. So, ooh, somehow my line got way thicker. There we go. That's fine. So the line goes in the getting bigger direction. And again, if I want to double check this one, I take the number that's in that direction, 11, greater than or equal to 10, and ask myself, is that true? That's called testing it, right? Using a test point. They kind of explain that over here. Okay. Is 11 greater than or equal to 10? Why, yes, it is. So that's correct. And we graphed it the right way, right? How do you know whether it's an open circle, closed circle? Look in your notes, right? Write it down. If it's equal to, it's a closed circle. All right. I went fast, but these are recorded notes, so you can always go back and listen to them again if you missed something.